Hi everyone. Today let's look at an important topic in system design called CAP theorem. So what we have here is a client application that tries to perform a read or a write operation, and we have two main servers S1 and S2 that facilitates the read and write for the client. We also have a load balancer that chooses one of the servers among S1 and S2 that will serve our client. Now, let's first discuss consistency. So, consistency states that every read should receive the most recent write or an error. So, let's take a scenario where the client is trying to write a data. It tells the load balancer, hey, I want to write some data. The load balancer chooses, let's say, S1 to serve this request. And S1 write data to itself, and after which let's say it communicates a success message to the client. Now, later on, let's say the client asks the load balancer that it is trying to read the same data. And in this case, let the load balancer choose S2, but the data is not present within S2 as we have only written it to S1. And we would be serving back the client that this data is not present, which is violates consistency as it states that the read should receive the most recent write or an error. Now, let's try to modify this a bit and make our system consistent. So, let's look at the same scenario again where the client tries to write something. It communicates that to the load balancer, and load balancer chooses S1 to serve this query. But let's make a little bit of modification here. There is a communication channel between S1 and S2, and when S1 writes the data, it also informs S2 to write that data to itself. Now, only after the write operation to S1 and S2 succeeds, we respond back to the client that a successful write has been performed. So in this case, as when the client tries to read that data later on and the load balancer, even if it chooses S2, we see that the data is present within S2. So S2 can also serve the client. Hence our system is consistent. Now let's discuss partition tolerance. What partition tolerance means is that the system should continue to operate despite the communication between the server nodes, which is S1 and S2 in this case, being disrupted. So let's take the same scenario as before, where the client tries to write something and the load balancer chooses S1. And as I mentioned before, for consistency, we need a communication channel between S1 and S2. And let's say S1 writes to itself, but then something happens and the communication between S1 and S2 got broken somehow, in which case we cannot write that data to S2. So what will happen? Well, S1 would communicate back to a client an error message for this write, as it cannot complete the write to S2 also. This is fine. The write message can result in errors, but our system is still partition tolerant. It is still able to function even when the communication between S1 and S2 has been broken. So yeah, system is partition tolerant now. Now let's look at what availability means. So availability means that every request receives a non-error response and the system is functional at all the time. So let's take the same example as earlier where the client tries to write a data and load balancer chooses S1, and let's have this communication between S1 and S2 for consistency. S1 writes to itself, but the communication between S1 and S2 got broken somehow. Now, earlier we were returning an error message, but for availability, it clearly states that every request should receive a non-error response. But in this case, we cannot serve the client upon the communication channel between S1 and S2 being broken. So we are forced to give this error message to our client. So our system is not available. In fact, this is what CAP theorem says, that no system can be all three, which is consistent, available, and partition tolerant at the same time. So that concludes CAP theorem, but there are other concepts that are closely related to what I have told here, which is eventual consistency and eventual availability. What this means is that consistency and availability, although may not be readily guaranteed by the system, they may be guaranteed in a time-bounded fashion. So what's interesting to note here is that a system could be available, partition tolerant, and eventually consistent, or a system could be consistent, partition tolerant, and eventually available. So that is plausible. So I also would link a interesting article explaining the CAP theorem in a very layman plain English language with the video. Hope you guys like this video. Looking forward to interact with you guys with my next video.